So hi, I'm Julian, as I mentioned, and I'm going to be talking about Radical. Some of you might have heard of it as a peer-to-peer code collaboration tool, a sort of decentralized IPFS-backed GitHub where you can host issues and submit patches and host your code without having a centralized server. And that is, in fact, part of what it is. But here I'm in the process of building that out. We've also built a platform, a programmable peer-to-peer platform. That is what I'm going to be talking mostly about today and demoing. The resolution is still not great, and some of it's still cut off. But a Radical, like many technologies that we've seen, like Cabal, like that, like OrbitDB, like SSB, is based on the idea of an append-only log. But what differs about Radical is that the data that goes into the append-only log is code. So when you think of an append-only log of code, of expressions, of data, code that's valid according to the semantics of the language, when you think of a log that way, what you end up with is something like a program. We call this a machine. And there's a slight difference between a program as we usually conceive of it and an append-only log of valid expressions in the language. And the difference is that this append-only log can still be appended to at any moment in time, whereas a program usually we conceive of it as having a fixed source code. So really, it might be more helpful to think of this as a REPL. And here, hopefully this will work. I'll try giving a demo, but of course with the screen being so cut off, I'm not sure if this is going to impress you. I swear that if it weren't for the screen, it would. So what I'm going to do here is, this is a REPL in the Radical language. So we have a deterministic language that I'm going to talk about in a moment. You might not be surprised to find out, given that I sort of mentioned treating data as code and code as data, that this is a dialect of Lisp. And I'm going to input an expression. I don't know if you can read this, but it says def ID new machine. So I'm creating a machine, an append-only log, that is IPFS backed and anyone can access and talk to. And then to that log, which anyone who has the name of the machine can submit expressions and query the state of the machine. And to that machine, I've sent a list of expressions, in this case containing only def a equals 3. And now I've printed out the ID of that machine so that I can use it. Now I'm going to copy that and start a new terminal. So now I'm going to start a new Radical terminal. This is running, both of these things are running my computer, but one of them could be running in yours and one in mine. Hopefully the internet here works sufficiently well. I'm going to load some of the things that I have for the talk in this.
Lack of internet is somewhat by design.
Yeah. This is almost at the stage where it works offline, but not quite. And so now here, I'm going to query this machine. And you might recognize this as an IPNS hash. I'm going to query it for the expression, let's say, a plus 3. Now here, a is not defined, but because I'm sending it to the machine where it was defined, well, you can't see the result, but it gives you the right result. So what happened here? So what happened here is that I have basically a REPL session running in the sort of distributed. Where exactly is it running? Well, the point is kind of that you don't have to care. This idea of something running in a specific location is sort of not exactly what we want to be doing once we sort of decentralize and have a peer-to-peer programming system. And so the way we achieve this is by making the radical language, which is the one that I've been using in this demo all along, deterministic. So this is a technique that you might know from replicated state machines, but this is more properly decentralized. So we have these machines that are deterministic, and so from the log alone, you can reconstitute exactly the same state. So if you're running this on your computer, you just ask IPFS and IPNS for the logs, and you get the logs of all of the expressions that have been submitted to this machine or REPL session. You run the radical interpreter, and you reconstitute exactly the same state. So it seems like we're all talking to the same server in some sense, because all of us get the same view, the same responses, the same behavior. But in fact, we're just sharing the logs and reconstituting them as needed. And this comes from the deterministic language that we use. Now, if you think about what's happening is we're basically putting a REPL to be accessible to everyone. And now anyone can contribute by submitting expressions to the REPL. This is really powerful. We sort of develop a prototype in the REPL, and now we can collaborate on it. And it's very easy to sort of give an example that's related to Cabal. It's very easy to define a chat application in that way, right? So we can, this won't be a surprise to anyone, but what I'm going to do is I'm copying some code. I'm defining a ref that holds a vector of a currently empty vector. I'm defining a function called say that just takes a message and appends to that vector. And I'm defining a function called logs that reads that ref, right? So this is nothing special. Anyone who sort of used a programming language won't be impressed by this. The difference, though, is that, again, for simplicity, because actually using, so there's no difference between my local REPL that I'm using here and a machine which anyone can communicate with. I'm using a local REPL because I don't have that much time, and resolving, sort of submitting expressions takes a little bit longer than it would using locally. But since I've defined these functions, if I were using a sort of a machine, as the one I defined previously, anyone in the room could use this function called say, and it would show up in my logs here. So if I do logs, it would show up as a message that I received. So we have a proper, semi-proper peer-to-peer messaging. There's a problem here. I can do the things I said, right? So I can write the function say hi, and call the function logs that shows that it's in the logs, sort of shows. But the problem is once you expose a REPL, oh, by the way, even, you might have noticed, but even the slides are being run in the REPL itself. So if I had bothered to make this publicly accessible, then you could, in your computer, say next and change my slide, right? So there's a problem. It's very, very easy. So this is the wonder of sort of peer-to-peer systems, right? I've just, in 5 minutes ago, I've created an entirely different machine, and without provisioning anything, anyone could, without sort of the deployment nightmare or anything, I've created something that you can already interact with. And I don't have to worry about hosting or any of these things, right? It was really, really simple, as you might have noticed. And because we start off from a REPL, it's very easy to submit, to program it in various ways and upgrade the system as it's running. But this is unsafe, right? I've sort of given everyone the power to interact with this REPL in any way they want. So if I wanted to, I could write ref, you could write ref chats, empty list. Oh, chat. Okay. And then after that, you've just erased all the chat history, right? So I don't want to give you access to that. So what we have is this notion of a TX, which is a function that runs on the input before normal evaluation. And you can use that to restrict the access, sort of remove power from the REPL. And so here I've defined the function TX. And now I've also somewhat facilitated the syntax. What I'm doing is if the expression I submit is a string, then I call say. If it's the keyword logs, then I show the logs. So now I can say hi, and it'll call the function hi. And if I say bye, it'll call the function bye. It'll say bye. And now if I use the special keyword logs, I'll see hi and bye. So now anything else that I try doing, if I try using the rest of the language, I'll get an exception saying only strings are allowed. In this process, I sort of locked myself out of my own REPL because I can't use anything else, including next. So I now, in practice, the way we handle this is that we usually make a bypass function for updates that only certain people in certain conditions can use so that you can go back to the normal REPL functioning. And you can update basically your chat application on the fly, right? It's running and then you can submit new functions to update it. So we have to use validation, no longer upgradable as we just saw, so I got locked out of my REPL session, right? The way in which we use this is for code collaboration. So the code for this, for these slides and my notes that I'm using to cheat here, they're both in a repo. And the way that repo works is entirely in a peer-to-peer way. And I can see, again, if the internet is okay, I can see an issue in my repo that says, give the talk. And I'll make this a little bit bigger. And I can comment on it saying, almost done. This takes a little while to update, but in a moment, if you check, there'll be a comment there saying that I'm almost done with my talk. And you can also submit patches through the system. But there are other applications that you can imagine doing. I'm going to go quickly through some extras. We're building a front end for this. So we've basically made the sort of dynamic what was previously a static peer-to-peer web, right? So with IPFS, you have static documents, and you can see those in the browser. And you can, of course, serve JavaScript, but you can't really interact with any server as such. Whereas this has sort of a distributed, decentralized server that you can interact with in the way that you normally think of a server. So you can build a front end for this, and we're building a front end for our issues and for our patches. So with a browser, you can interact with it, and you can have gateways. In fact, the way we've designed it is that every computer can serve as a gateway. One thing that is really, really exciting that I won't have time to talk about is that that I think is actually the most exciting part of this, is that these machines are transparent and verifiable. So we can't really, so there's some prior art with Paul Fraze's Node.vms. Paul Fraze might be here. You could ask him about it. And so the idea here is that anyone can verify that a web application or a website is behaving according to the source code in Radical that they claim that they're using, which is not true in the web generally. So this enables a lot of new possibilities in terms of really transparent, auditable services. I'm not going to go into all of the possibilities because I have to stop, and I'm out of bounds. Yeah. So the link is radical.xyz. Radical is radicle.xyz. The unfortunate thing is that we call everything the stack Radical, so including the code collaboration tool and the platform. So it's a little bit confusing. We'll split the names eventually. So if you go to radical.xyz, you'll see the code collaboration platform described and some links to how it's implemented. We're also having a meetup, our first meetup on Full Node on the 11th, if you want to join. Yeah. And if you have any questions, please come talk to me. Thanks a lot.